Everything we did so far, only one number was given for a reactant. When more than one number is given for the reactant, we need to determine what is limiting and what is excess. Let's look at this example. I am starting with 6 cupcakes and 5 candles. So these are my reactants. To produce the perfect birthday cupcake, each cupcake must have a candle. I start off with 6 cupcakes and I have 5 candles. To produce the perfect cupcake, which must consist of 1 cupcake and a candle, I can only produce 5. What is preventing me from producing more? It is the candle. So the candle here are my limiting reactants. And since I have 1 more cupcake left over, this is my excess reactants. If I start with the candles, which is the limit, I can make exactly 5 perfect cupcakes. I can make exactly 5 perfect birthday cupcakes. But if I start with my excess reactant, I can make 6 perfect birthday cupcakes. But one of them will be missing a candle, so it would not be perfect. So the leftover, since there is a leftover, this is my excess. So we cannot produce more than what is preventing us, and that is the limiting reactant. Limiting reactant or reagent prevents more products from being formed. You will always have less of it. At the end, none of the limiting reactant will be present. Excess reactant or reagent you will have more of at the end. There will be leftovers. The general rules for working out stoichiometry problem is, again, write a correct balance equation. You will know it is a limiting or excess because information will be given on both reactants. Sometimes there might be 3 reactants, and if it's given on all 3, you need to still figure out which is limiting. Remember, limiting is all used up. Excess is what is left over. So let's look at this first problem. If 6.3 grams of sulfur reacts with 10 grams of oxygen, what is the limiting reactant if sulfur trioxide is produced? Step 1, you want to write a correct balance equation. So sulfur reacts with oxygen. Oxygen is a diatomic, so you write O2. Produces sulfur trioxide. Sulfur is a nonmetal. This is a covalent bond. Prefixes become subscripts. So this becomes S. O. Tri is 3. So SO3. Next, we need to balance. The sulfur is balanced, but the oxygen is not. So we need to find a common factor. The common factor is 6. So I need to multiply the oxygen by 3 and the sulfur trioxide by 2. The oxygens are balanced, but since I have 2 sulfurs on the right side, I need 2 sulfurs on the left side. So my coefficients are 2, 3, 2. We have 6.3 grams of sulfur, 10.0 grams of oxygen. Since information is provided on both reactant, we need to do stoichiometry twice. We're going to start with what's given, which is 6.3 grams of sulfur. Diagonals must be the same, so grams sulfur. There's 32.07 grams of sulfur in 1 mole of sulfur. This is off the periodic table, which is molar mass. Grams of sulfur cancels out. We go to moles of sulfur. We need to go to moles of sulfur, diagonals. In this problem, it doesn't ask what to solve for. all it wants to know is what is the limiting reactant. So we could just pick the product and solve for the product because we could determine that. So we're going to solve for moles of SO3 because this is mole ratio. The number in front of moles is the coefficient of the balance equation. So moles of SO3, there's 2. The moles of S, there's 2. I could stop here, or I could go to molar mass, or I could go to volume, or I could go to Avogadro's. But if I know the number of moles of SO3 produced, I could still determine what the limit is. So I'm going to repeat the procedure with oxygen because 2 reactants are provided. So this is grams of oxygen. So grams of oxygen, diagonals have to be the same. We know this is molar mass, so 1 mole of O2 is 32 grams. Off the periodic table, the grams of O2 cancel out. We don't want moles of O2, so we need to do diagonals again. Moles of O2. To compare what is the limit or excess, we need to solve for the same thing. So if I have moles of O2, we need to solve for moles of SO3 because we solve for the moles of SO3 on top. The number in front of SO3 is 2. The number in front of moles of oxygen is 3. So multiplying the top, 6.3 times 1, the 2's cancel out. Divided by 32.07, you get 0.19644. For the bottom one, 10 times 2 divided by 32 times 3 gets you 0.2083. So by looking at the answers, you notice that sulfur produces 0.196 moles of SO3, while oxygen produces 0.208. So my sulfur here is my limit, and my oxygen here is my excess. Stoichiometry can be solved in many different ways. Here we solve 2 moles of SO3. However, if we wanted to go to molar mass and solve for the grams of SO3, we would still find the right limit. We could have gone and used Avogadro's and solved for molecules of SO3, or we could have gone to STP and found a volume of SO3. We could have also started with 6.3 grams of sulfur and solved for oxygen and compared the grams of oxygen given to what is used, or vice versa. We could have started with 10 grams of O2 and solve for sulfur and see if we had more or less. Pause this video, solve the problem, and then check your answer. First thing you should have done was start with a correct balance equation. We have calcium carbonate mixed with hydrochloric acid. Since both of these are compounds, this is going to be a double replacement reaction. So calcium and hydrogen are going to replace each other. Remember, hydrogen in the beginning behaves like a metal. So calcium's new partner is going to be chlorine crisscross. So this is going to be CaCl2. And H's new partner is going to be carbonate crisscross. So it's H2CO3. Carbonic acid is unstable, so this is CaCO3 plus HCl yields CaCl2 plus H2O plus CO2. We're going to balance. There is 1 calcium on each side. There is 1 carbon on each side. There are 3 oxygens on the left side and 3 on the right side, 1 from the water, 2 from the CO2, and we have 2 hydrogens and 2 carbons, so we need a 2 in front of HCl. Now it's balanced. So if I read my problem, I have information on both reactants. I have 68.1 grams of calcium chloride, and then we have 51.6 grams of HCl, and we're looking for carbon dioxide. So that means I need to do my stoichiometry twice. So I'm going to start with 68.1 grams of calcium carbonate. Diagonal units have to be the same, so grams of calcium carbonate. Grams of calcium carbonate, this is 100.08 grams of CaCO3 to 1 mole, molar mass. Moles of calcium carbonate, and we have to convert to moles because we want to go from a one element compound to a different element compound. We're going to go to moles of CO2. The coefficient for both of them are 1, so this is 1, 1. Moles of CO2, because they want mass. 1 mole is 44.01 gram of CO2. Multiply the top, multiply the bottom, and divide, and you should get 29.947. I'm going to repeat this for hydrochloric acid, so I'm going to start with 51.6 grams of HCl. Diagonals, grams of HCl, which is 36.46, 1 moles of HCl, moles of HCl, mole ratio to go to one element and compound to a different one, to CO2. There is a coefficient of 2 in front of HCl, 1 mole. Moles of CO2, diagonals have to match, moles of CO2. This is 44.01 grams of CO2 to 1 mole. Multiply all the top, multiply all the bottom, divide, and you should get 31.143. So my limiting reagent here is calcium carbonate because I produce less. So this is my limit. HCl is my excess. So how much of the CO2 is produced? It's going to be 29.47. There is 3 sig figs, so my answer is going to be 29.9 grams of CO2. Pause the video, try this problem on your own, then check your answer. Determine the compound produced when 2.2 magnesium is reacted with 4.5 liters of oxygen at STP. So the first thing we're going to do is write a correct balance equation. So magnesium plus oxygen, which is a diatomic, O2. Since we have an element and an element, it's going to form a compound. So this is a synthesis reaction or a combination. So this is going to be MgO because the charge of magnesium is 2, charge of oxygen is 2, they reduce out. So we have 2.2 grams of magnesium and we have 4.5 liters. So we need to find how much compound is produced. Since they didn't tell you to solve it in any particular unit, you could decide, I'm going to solve 2 grams. So we're going to start with 2.2 grams of magnesium. So diagonals grams of Mg, which is 24.31 to 1 mole off the periodic table. Grams of Mg cancel out, so moles of Mg. We're going to go to moles of MgO. The balance equation, the coefficients are both 1, so this is 1, 1. And we said we're going to solve to mass. I could solve to moles. It doesn't matter because nothing's given. So moles of MgO, So 1 mole of MgO off the periodic table is 40.31 grams of MgO. We get approximately 3.647. We're going to repeat the procedure for our oxygen. So we have 4.5 liters of O2. Liters of O2. This is molar volume because it's at STP. So 22.4 liters to 1 mole of O2. Moles of O2. Coefficient is 1 again. 1 mole of MgO. The moles of O2 cancel out. Moles of MgO. 1 mole of MgO. Molar mass 40.31 grams of MgO. Multiply the numerator multiply the denominator and then divide. You should get 8.0979. So here my limit is the magnesium, because we only produced 3.6, so my limit is my magnesium. My excess is my oxygen. So my correct answer for the amount of MgO produced is 3.6 grams of MgO. Pause the video, solve this problem on your own, and then check your answer. So first thing we're going to do is write a balanced equation. We have methane. Methane reacts with water to produce hydrogen gas. Hydrogen is a diatomic, so H2 plus CO2. Next thing, we need to balance it. We have a carbon on each side. We have 6 hydrogens, 4 from here, 2 from here, separated by a plus on the left side, but we only have 2. So if I put a 3 here, my hydrogens balance. However, if I look at my oxygen, on the left side it's odd, but the right side it's always an even. So what I need to do is I need to make my oxygen even first by putting a 2 here. So if I put a 2 in front of water, my oxygens are balanced, my carbons are balanced. So let's find the total hydrogens. So let's count the hydrogens. So we have 4 from the methane, plus 2 times 2 is 4, so there's a total of 8. So I need a 4 in front, so that makes it 8. So this is a balanced equation. So if I look at this problem, it says how many liters can be produced from 80 grams of CH4 and 16.3 grams of water. Since information is given on both reactants, we have to do the stoichiometry twice. So I'm going to start with 80 liters of CH4 methane. Diagonals, gram CH4, 1 mole CH4, which weighs 16.04. Grams cancel out. Moles of CH4, moles of CH4. Coefficient is 1. We are looking for hydrogen in liters, so this is going to be 4 moles of H2. Moles cancel out, moles of H2, moles of H2. 1 mole, since we're going to liter, is 22.4 liters of H2. So we're going to multiply the top, multiply the bottom, and divide. You should get 446.88. We're going to repeat the procedure with the water. So we're going to start with 16.3 grams of water, 18.02 grams of water to 1 mole of water. The diagonals cancel out. Moles of water, moles of water. There are 2 moles of water because the coefficient is 2 to 4 moles of hydrogen. And we're going to go diagonals again. 1 mole of H2, since we're molar volume, that's 22.4 liters of H2. Multiply the top, multiply the bottom, and divide. You should get approximately 40.52. So this tells me my limit is my water is my limit because it produced less, and methane is my excess. So the amount of hydrogen produced with correct sig figs, since there's 3, is going to be 40.5 liters of H2. Continuation, how much of the excess was left over? So my excess is CH4. So starting with my limit, or you could start with 40.5 liters of H2, you need to find how much of the excess is used. I'm going to start with the water. Grams of H2O, diagonals have to be the same. So grams of H2O, 18.02, 1 mole of H2O. Diagonals cancel out. Moles of H2O to moles of methane. Coefficient of methane is 1. Water is 2. So we need to go to grams because these are given in grams. So moles of methane, 1 mole is 16.04 grams of methane. Multiply the top, multiply the bottom, and then divide. 7.254. There are 3 sig figs, so this becomes 7.25 grams of CH4 used. Since I started with 80 grams and 7.25 is what is used, this is what I started with. This is what I used. I need to subtract these. 72, 75. I need to round here. So it's going to be 72, 72.8 grams. This is a 7, rounds up. This is the last significant digit. This is the last significant digit. We round to the least precise position.